All right, so here's our math objective for today. I will be able to apply what I know about fractions and use tools to solve fraction number stories. So I think that you guys would remember that a number story is basically a word problem. And we've learned how to chunk up the information in the word problem so that way we know how it makes sense. We're not going to be working on chunking up anything, but it's more about making sense when there are fractions in our number stories. Okay, so your math warm-up today is you're going to identify if the fraction is greater than or less than half, okay? So is half greater than or less than 0 halves? And one of the ways that I like to double check is by using a piece of paper. And actually, I like doing fraction strips for myself. I like it a little bit better than using fraction circles. But if fraction circles are what you will want to use for this practice, then that is fine as well. So what I'm going to do is I'm going to make one fraction strip, and I'm going to label this one for half because I know that I'm going to be comparing fractions, and all of them are going to be compared to half. So there's 1/2, and then my next fraction that I am actually comparing, let's go back to the screen. Is 0 halves. So is 1/2 greater than or equal to or less than 0 halves? So that tells me if I have half of a fraction strip, is that more or less than no halves of a fraction strip? I would say that it's more. Now, when you're doing your fractions, remember greater than is going to point to what is the bigger piece. Okay, the mouth points to the bigger piece. So it would actually be the other way. It would be like that. Yeah, it would be like that. So when I'm going to type it in here, I'm going to do the mouth is open to the bigger piece. Okay, so let's do the second one. 1/2 is greater than or less than 2 halves. So when I go back to my hovercam, that's 1/2, and this whole thing would be 2 halves. And I know that that is actually greater than. So let's shade that. So 2 halves is greater than 1/2. And so the mouth needs to be open to the bigger piece, so like that. Now, is 1/2 greater than or less than 1/4? Well, let's look at the hovercam. My eraser. Because this is split into halves, I need to split it into fourths. And it was 1/4. So, is 1/2 greater than or less than 1/4? It is greater than, so I would go back and I would put that it is greater than. Okay? So that is how you do this assignment, or your warm-up, I should say. And so that is there for you to do. You're going to compare 1/2 and 3/4, 1/2 and 4/4, 1/2 and 2/6, 1/2 and 4/6, 1/2 and 5/6. All right. So then you're going to use your ruler and draw a line segment that is 2.5 inches long on your slide. Partition the line segment into 1/2 inch lengths. So the way that you're going to do that is you're going to use your line tool up here, okay? And you're going to create it to 2.5 inches. So let me see. I've got 0, 1, 2, and then halfway. So this is where I want my line to end. So I could actually even start it right here as I create my line. And I got to stop it at the 0. All right. And I want my line to, I could change the color. I can make it purple and I can make it thick so that way it's really easy to see using these tools up here. Okay. Now it says I need to partition the line segment into 1/2 inch lengths. So I'm going to continue to use my line tool and go to the 1/2 inch mark. So this is 0, this is 1, so this is a 1/2, and this is where I'm going to mark that. Now, the next 1/2 inch mark is actually the 1, right? Because this is 0, then this is a 1/2, and this is another 1/2. Just because it lines up on the 1 doesn't mean anything. It means that it's still a halfway mark because the distance between these two is the same. And then you're going to continue on and finish that up. All right. So go ahead and pause and complete the math warm-up and creating your line, and then come back in 5, 4, 3, 2, 1. Okay, so this is the line segment that I drew, okay, and I put in all my halfway marks. How many 1/2 inch lengths are there? So really, you don't just count these guys. What you're counting is the length in between. So this is going to be a 1, 2, 3, 4, 5. That's what I got. Since there are 5 1/2 inch segments, the line segment is 5 1/2 inches long. 5 1/2 inches is another way to write 2.5 inches. Does that make sense? Because when you're looking at this we know is 2.5 inches, and it actually takes 5 1/2 to make 2.5. Your partition line segments are similar to a number line, just like this, right? We have our 0 1/2, 1 1/2, 2 1/2, 3 1/2, 4 1/2, and 5 1/2, and it lands at the 2.5 mark on a ruler. I wrote a number story to match the drawing. Caitlin has 2 beads that are each a 1/2 inch long. When she lines up the beads end to end, they are 2.5 inches long altogether. How many tube beads does she have? Each 1/2 inch line segment represents 1 tube bead. So there are 5 1/2 inch lengths. So there are 5 tube beads. So if I wanted to show that on my hover cam, I know that I have 2.5. Okay, so I know that this is going to be 2.5 from 0. Okay, and so I know that this is going to be probably, this is 2, this is 1, and then I've got my 1/2, my 3 1/2, this is going to be 2 1/2, 4 1/2, and 5 1/2, right? And these are the beads, right? So here's a bead, here's a bead. We've lined up all the beads end to end, and they're each a 1/2 inch long, and we have 1, 2, 3, 4, 5. Okay? You might want to draw something similar to this right now, because the problem is about to get just a little bit harder, and you're going to have to solve. Now, draw pictures to help solve this story. How many more beads does Caitlin need in order to make a bracelet that is 6.5 inches long? Okay, and this is where you're going to put your answer. All right, go ahead and pause the video. Go ahead and draw this out. And remember, 1 bead is going to be a 1/2 inch. Okay, so how many beads does it take to make a 6.5 inch long bracelet? Knowing that we've already used 5 to make 2.5 inches, okay? Because it's asking how many more beads, all right? So go ahead and solve that and come back in 5, 4, 3, 2, 1. What is the total number of 1/2 inch beads it will take to make a 6.5 inch bracelet? So I hope that you didn't erase your work, because now it's just what is the total to making the 6.5 inch bracelet? How many of those 1/2 inch beads do you need to make that bracelet? What is an equivalent fraction for 6.5? And I'll give you a hint of how you know. It is because of this. If I'm going all the way to 6.5 instead of 2.5, how many halves do I need? So for instance, we knew that this is 5 halves. So what would be under 6.5? What would that halves fraction be? Here, this is what you're going to solve. And you can draw pictures to help you figure this out. 4 friends share 5 granola bars equally. How many granola bars does each friend get? So go ahead and solve and pause and complete this slide, and I will be back with you in 5, 4, 3, 2, 1. Okay, so we have a number of strategies in order to solve that problem. In this strategy, you can cut each bar into 4 pieces and give each person 1/4 of each bar, right? Because I have 1, 2, 3, 4, 5 bars and 4 people. So let's say I've got myself, Malia, Ella Grace, Josiah, and Noah. And so then this piece would be for me, this piece would be for Ella Grace, this piece would be for Noah, this piece would be for Josiah. And then you go like that. In this strategy, you could cut each bar in half, right? So this one's for me, this one's for Ella Grace, this one's for Josiah, this one's for Noah. And then you keep going like that. And then at the last bar, you actually cut it into fourths. So we each get 2 halves and 1/4, okay? Or lastly, in this strategy, you give each person 1 whole bar because there's 4 of us, right? So each of us gets a bar, and then we're only splitting the last one, okay? And then each of us gets 1/4. Now, take a look at each of these, right? How do you know that these fractions show the same amount? Well, we have each one was separated out in a different way. And even how you might have solved this could have been separated out in a different way. But all of these are going to be equal because 2 halves is basically a whole, right? And then I get another 1/4. So I get 1 and 1/4. Then this one is the same. I get 1 and 1/4. And then when I add up all of these, I get 1, 2, 3, 4. So once I get 4/4, I know I get a whole, right? And then I get an extra 1/4. So how do I know that these fractions show the same amount? And put your answer right here. TJ walks 3/6 of a mile to get to school. Andre walks 3/8 of a mile to get to school. Who walks the greater distance? What tools can you use to solve this problem? We can use the fraction number line. And I think it's great to use the fraction number line because we are comparing 6ths and 8ths. And sometimes it's easier to see that on a number line rather than in fraction circles or even fraction strips, because once the pieces start to get really small, it's a little harder to see. So I am out of time on this video, and I will see you in the next video.